Hi everyone. In this video, I'm going to go through how to set up an assignment from GitHub Classroom that has starter code and how to run unit tests that's in that starter code that use Google Test, the Google Test framework. All right, so here's how this is going to work. Your instructor is going to provide you, as usual, with a link for GitHub Classroom. Okay, this is unique for each assignment. So this is my programming assignment number 3 link. So you'll click on this link. For me, it's always in the programming assignment specifications. Okay, it's going to create your repository by cloning the starter code that I've set up for the repository. Okay, and this can take a long time. Okay, I found that during the day, like peak times, like 8 to 5, it takes a little bit longer than it takes when I accept at night, like after 7 or 8 or whatnot. So if this takes a while, don't worry. Maybe, go get a snack, go do something else, and then come back and check it in, 10, 15 minutes. It should be done for sure by then. All right, so when this is done, you'll click on the link to your repository. Okay, and you're going to see it's not empty, right? So this has files in it, right? There's starter code that was copied into this repository. This isn't empty, okay? Which means we're not going to go to our virtual machine or to our development environment and run git init in a folder and then add a bunch of files, add a remote, and push up. Okay, we're not going to do that because this isn't an empty repository. What we're going to do instead is we're going to come over to the clone or download button and click this copy button to copy the URL. And we're going to clone this existing remote repository to our local machine, okay? And there's already going to be a connection between our local repository and this remote repository because we're cloning, okay? So with starter code, you do not need to run git init and you do not need to run git remote add, okay? That's already done and set up when we clone, okay? So copy this and then head over to your development environment and cd to a directory in your terminal where you want to work on your programming assignment. So I'll just work on the desktop and I'm going to run git clone and then I'm going to paste that link that I copied from GitHub and it's going to copy down all of these files in this folder in this remote repository to a local working copy, a local repository where I can then work on my programming assignment. Okay, so I do an ls, and there's that PA3-gsprint23, PA3-gsprint23. So this is the local repository that's connected to that remote repository. So go ahead and cd into that PA3 folder. And if you do an ls-al, it's a little bit bigger so we can see. If you run an ls-al, you're going to see all of the files and folders that were in the remote repository in your local repository. You're also going to see a .git folder, okay? This .git folder, it's a hidden directory. This is what tells you this folder is a repository, okay? This is what keeps track of all the changes and all the commit history, the remotes, etc. in this repository, okay? So we don't need to run git init because we already have .git, and we don't need to run git remote add because we already have an origin set up. Okay, and in fact, I can run git remote and it's going to list all my remotes and look, there's already an origin. Okay, so no need to run git remote add and no need to run git init. All right, so there's a readme, readme.md file in this folder. README files, as their names imply, are files that should be read. Okay, so readme.md files, if they're named exactly that, then GitHub will render them on kind of the main page of the repository. So here's the README file rendered on GitHub, okay? And this has the information that I'm about to walk through right now, okay? So this is gonna be a little bit different than any of your previous programming assignments where you start from scratch, right? You make your main.cpp. If you're doing multi-file compilation, you might have another CPP file and a header file. You run G++ for your C++ files, it creates like an a.out and you run it, okay? The big picture's the same here, but with this starter code, there's a certain infrastructure that's gonna make our compiling and running a little bit different, okay? And that infrastructure that's different is this program or this assignment is set up to use something called Google Test, okay? Google Test is a framework for running unit tests. And what's nice about these unit tests is they're going to tell you if your code is on the right track, if it's on the way to working correctly. Okay, so I've written the unit test, or your instructor's written the unit test. Now you just need to work on your code like normal, meeting the requirements of the programming assignment, and you can check in with the test cases to see if your code is functional enough to meet the test cases, make the test cases pass. All right, so let's get to the point where we can write some code and run the test cases. All right, so here's what we're gonna do. We're gonna follow these instructions. It says to set up one time only. Okay, we just ran git clone. Okay, we did that. We CD'd into the local repository we just cloned into. Now we're gonna run make dir to make a directory called build. We're gonna CD into that build directory, and then we're gonna run this little utility called CMake. Okay, we're gonna run CMake in the parent directory, .. All right, so mkdir build, cd build, okay. There's nothing in the build folder, I just made it. And now I'm gonna run CMake ... So CMake is a utility, a little program that is going to process the CMake list.txt file, which when I'm in the build directory, CMake list.txt is in the parent directory, which is why we run CMake ... Okay, it's gonna parse this CMake list.txt, which kind of provides CMake information about the structure of this folder, of this project, so that CMake can make something called a make file, All right, so I'm gonna run this. Okay, so it says command CMake not found. Okay, if you see something like this, no need to panic. Okay, so we'll just run sudo apt install CMake. All right, looks like CMake was successfully installed. So let me try running CMake again. Okay, so when CMake runs, you're gonna see a bunch of work being done on your behalf, which is awesome. It says build files have been written to your directory and then the build folder, which is why we made the build folder, because now if I run an ls-al, look, there's a lot of other files in here, and I put them in the build directory so that they don't clutter up our top level PA3 directory, which has our source files. Okay, we like to keep our source files separate from our build files to keep the organization of our project clean. All right, so this right here, this make file, okay? Think of the make file like a script or a program for building your project, okay? It's like running that G++ and then the name of your C++ files, but for a more complicated project structure. You can open the make file if you want. It's gonna look kind of long and intimidating. Make files don't need to be long and intimidating, but because CMake made this make file, it's got a lot of info in it. All right, so make file is there, great. Now, in order to compile, each time you make a change to your code, you wanna compile, you're gonna be in the build directory and you're gonna run make, okay? So make is your new G++, okay? Just run make, and it's going to compile the code that you're writing, and I'll show you where the files are that you should write your code in, and the test code, okay? That's the key. It's gonna compile both your project, your PA3 project, and the tests for the PA3 project, okay? So I'll run ls-al again, and now you can see there's an executable here called run PA3. Okay, this is your a.out. Okay, when you want to run your program, you're going to be in the build directory and you're going to run /run PA3. Okay, nothing happened because the main function, which I'll show you here next, doesn't have anything in it. It's empty. Okay, so this is like your /a.out, run PA3. Okay, so that's what this next step here says. To run the main function in the build directory, run /run PA number, where the number is the programming assignment number. So in this case, it's PA3. All right, so let's go take a look at the main function and see if we can change it, compile our code again, and then run our code and see some output or see that change. All right, so cd out of directory, ls-al, okay? Here are the files that you are going to modify for this assignment. main.cpp, pa3.cpp, pa3.h. Okay, that's the 3 file format that we've been working with. Okay, those are the 3 files where you're going to write your code. Okay, numbers.txt is an input file that you may mess around with and change to test your code. That's totally fine. Same thing for input words.txt. Okay, don't touch .getIgnore, don't touch .get, don't touch CMake list.txt. You know the build directory, that's what we just created. No need to touch the README. No need to touch the test directory, though you might want to poke around in there. I'll show you what that looks like here shortly. And then no need to touch the .travis.yaml file. Okay, ignore this file as well. All right, so let's gedit main.cpp. Okay, so here's main. It only has one line of code here, seeding the random number generator, and I wrote this should be the only call to srand in PA3. Okay, so don't write srand anywhere else in your code. Okay, it's seeded right here, the first line of code in main. All right, it looks like there's 3 tasks for this programming assignment. So here's where you'll call your functions for task 1, for task 2, and task 3 that are written in pa3.cpp and have their prototypes defined in pa3.h. All right, so let's say I put a cout statement in here and I say starting on task 1. Okay, this is just a standard main.cpp like we've been working with. But in order to compile the code, what we're going to do is we're going to run that make command inside the build folder. So I can do, I'm not in the build folder currently, so I can do /build/make, let's cd into the build directory. And then we run make. All right, so now in here, I can run PA3. And there I see starting on task 1. All right, so here's how you can modify main.cpp, pa3.cpp, and pa3.h and compile and run your code just like before. But the real benefit here, why the whole reason we have this whole structure is for these unit tests, okay? So at any time, you can see how your code is progressing by running the unit tests and seeing if your code passed any of the test cases. So here's how you run your unit tests. Okay, you're going to do /test/run tests. Okay, so this is a folder in the build directory called tests, and in tests, there's run tests, and this is an executable, just like a a.out or just like the run PA3. And it's going to run unit tests against your code, okay? And your code is what you've written in main.cpp, pa3.cpp, and pa3.h, okay? So this says that there are 4 tests, okay, listed below. Task 1, computations. Task 2, find lottery ticket. Task 3, create words array. And task 3, generate random sentence. Okay, and it says passed, 0 tests. Okay, so all 4 of the tests have failed, which makes sense, right? That's what you have to write. You have to write code according to the programming assignment specification that when implemented correctly, you run these tests and they will pass. All right, so here's what I want to do because I know this is so new for everyone. I want to go through and help you get started on task 1 such that the first test case passes. That way you can see what it looks like. All right, so let's cd back out of directory. Let's gedit pa3.cpp and pa3.h. All right, so here's pa3.cpp. Here's task 1. it says finish the function and define call 3 additional functions, okay? So the functions that are already defined in this file, there's 4 of them. They directly correspond to the 4 test cases, and you cannot modify the function prototype or the function header, okay? So you can't change the name, you can't change the return type, you can't change what it accepts, okay? So what this does is it accepts an integer called num and 3 pointers, a pointer to a Boolean called isMultiple, a pointer to a Boolean called isSumEven, and a pointer to a Boolean called isPrime, okay? So given a number, we want to find out, is this number a multiple of 7, 11, or 13? Okay, this is all in the specs. 7, 11, or 13. Is the sum of its digits even? And is the number prime? Okay, so we have one function that is going to answer 3 questions about this first argument and return the result via output parameters that are pointer to Booleans. Okay, pointer to Booleans. All right, so I need to call a function to answer the first question. Okay, so is num a multiple of 7, 11, or 13? All right, so I'm going to define a function I'll call, say, bool is multiple 7, 11, 13. 7 or 11 or 13. And so it's going to accept a value and it's going to return a Boolean, true or false. All right, so if num mod 7 equals to 0, then I know this number is a multiple of 7, okay? Or if this number mod 11 equals 0, I know it's a multiple 11. Or if this number mod 13 equals 0, then I know it's an integer, or a multiple of 13, okay? So this is an or, it doesn't have to be a multiple of all 3, okay? So I'm using the logical or operator here. All right, then I'm going to return true. Otherwise, I'm going to return false, okay? Like 5, for example. 5 isn't a multiple of 7, 11, or 13, so none of these mods are going to give me 0. In fact, they'll all give me 5, which case I'll return false. All right, so let me call this function, and I'm going to take the return value of this function and put it to be the contents of what the pointer isMultiple points to. So isMultiple's contents is assign the return value from isMultiple 7 or 11 or 13. Not the prettiest named function, but that's okay. Okay, I should add a prototype for this to the header file, which I'll do that now. So I'll copy this. Look, it even says right here, to do, add your additional function prototypes for task 1 here. All right, make sure all my files are saved. Okay, I'm going to cd into that build directory. Okay, and I'm going to run make. Okay, it looks like my code successfully compiled. I can run it with run PA3. Okay, it says starting on task 1. Okay, I didn't actually add any more cout statements here. Okay, and now I'm going to run my test case. Okay, and they're all still failing. Okay, because I've got 2 other pointers here that I'm not setting the contents of what they point to be actual answers. Okay, so let's take a look at the test case and see if we can maybe just try and force one of them to pass, but we do want to, write the solution for the functions. All right, so the test cases are written in the PA3 directory in the test directory. Okay, so cd test, do an ls-al, and you'll see there's another CMake list.txt. No need to touch that. There's a lib folder. This is with the library for Google Test. No need to touch that. There's test.cpp. So this is the C++ source file that has all of the unit tests in it that are executing when we run tests. And then there's a verbs.txt. Don't touch that either. That's used by test.cpp. So let's open test.cpp. Okay, so here's test.cpp. You can see that it uses the pa3.h file that you can modify. That's how it knows what to call and where to call it. All right, so each one of the test cases or test functions start with test. Okay, so here's task1.computations, which if I scroll up, task1.computations, okay, it's right here, it's failing. Okay, so let's look at it. So it looks like it calls answer integer questions 1, 2, 3, 4 times, 4 different times, each with different numbers. Okay, so the first time it calls it, it's passing in 77. Okay, so 77 is a multiple of 7, 11, or 13, right? For example, 7 goes into 77 evenly 11 times. Its sum of its digits being even is true, right? Because 7 plus 7 is 14. 14 is even, true. Is prime is false, right? Because 77 is divisible by 7, for example, it's not a prime number, okay? So when you successfully finish the answer integer questions function, you'll have set values for is multiple, is sum even, and is prime, such that when we test them, expecting them to be equal to true, true, false, this part of the test case won't fail, okay? But it's got to work for these other test cases as well. So if we scroll up in our output, we can actually see output from each of the unit tests in more detail, right? So right here, let's scroll up a little bit more. All right, so right here is the beginning of running our test. So here it's running one test from task 1 computations. We're looking at the test cases, or the test case right here. All right, so it says value of true, expected true. Okay, so this test case right here is fine, right? Value of true, expected true, that's fine, okay? But then the next one is prime, right? It says right here that the value of false, right? It should be false, but it's actually true, okay? So that one isn't fine, that one fails, okay? So what you need to do is finish this function right here, answer integer questions, such that you set is sum even and is prime properly, and then these will go through and they should all match, right? So true, true, right? And this one should be false, 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 etc. Okay, so once all of these go through and they match, then this test, task1.computations, is not going to fail. It's going to say okay, meaning that it passed, okay? So let me go ahead and help you get started. So we're here in pa3.cpp, okay? You're gonna write one more function here to answer the second question, okay? So you might have something like the contents of is sum even gets is sum even for num, passing in num, something like this, call it some function. Write this function, go through, and for each number or each digit in number, determine if the sum of it is even or not, return true or false, stored in this bool pointer, what this points to, and do this for the third question. And then if you implemented all three of these functions correctly, run your test case again and see if that first one passes. Okay, it'll say right here for task 1 computations, okay. Once that's passing, you should feel comfortable that your output is correct. Okay, it doesn't mean you're done, right? You want to go back and maybe refactor your code and comment it. provide, what you need to meet the coding standard, but that should give you at least peace of mind that your output is correct. All right, so that is kind of the high-level overview of our new structure for programming assignments. I know that it is a lot, but watch this video as many times as you need to in order to get comfortable with the structure, okay? What you need to know is listed in the README file, okay? Here's a summary of how to run the unit test. Here's what you can modify, what not to modify. Okay, if you can identify these 3 files, main.cpp, pa3.cpp, and pa3.h in the top level pa3 directory, okay, you can open those up in gedit or whatever text editor you use, and you can take a look at those, modify them just like you would for previous programming assignments. The only thing different here is in order to compile your code, you got to head over to the build directory and run make. And in order to run your code, also in the build directory, you run /run pa3. All right, the test cases are there to help you and give you a sense of more of a real-world project, right, where our files are growing, our project structure is growing, and a lot, almost, I'd say all companies, all software projects write unit tests in order to check and make sure their code is always in a correct and hopefully bug-free state.